Welcome to EDU World Space.
Hey guys, we're doing problem number 96 of chapter 9 in chemistry, the central science. So they want us to predict the electron domain geometry around the central atom in xenon difluoride, xenon tetrafluoride, and xenon hexafluoride. So let's look at our molecular geometry rules. We have our Lewis structures here, so let's look at xenon difluoride. So we have 3 lone pairs around xenon and two bonds. So first we go down to a trigonal bipyramidal structure. That's going to be our electron domain geometry. And then we're going to look for the structure with 3 lone pairs and two bonds, and that's going to be a linear structure. Now for xenon tetrafluoride, we see 4 electron domains surrounding it. So that's going to be octahedral electron domain geometry structure. Now let's see what happens when. Now let's look at molecular geometry. So if we have 4 bonds and 2 lone pairs, this is going to be a square planar structure. Now this one is going to. Now xenon hexafluoride is going to be interesting because you'll notice it's surrounded by 7 electron domains. So that tends to be more than what we're used to. So we're going to look at the electron domain geometry. If you're surrounded by 7 electron domains, you form what's called a pentagonal bipyramid. And pentagonal bipyramid is where 5 of the fluorines would be equatorial, forming a flat pentagon around the central atom. And then your other 2 fluorines are you have one above. You have 1 fluorine above and 1 below your central atom. So that's going to be your electron domain geometry. Molecular geometry is actually going to look like a distorted octahedron. So it's going to look like this is what we call a monocapped octahedron. It's difficult to actually determine what the specific geometry is, but we know that the geometry is going to be octahedral, but slightly different than what we expect from a regular octahedral structure. So now we're doing part B. The molecule IF7 has a pentagonal bipyramid structure, and as I told you before, 5 fluorines forming an equatorial plane with a flat pentagon, and around the central iodine atom, and the other 2 fluorines are axial. You'll have one below and one above the central atom. So they want us to predict the molecular geometry of IF6 minus. So let me see if I can make this smaller. So let's draw IF6 minus. So we're going to have, let's just draw our I surrounded by 6 Fs. So put our lone pairs on our fluorines. So we got 7. We got 6 fluorines surrounding it. Oh, and don't forget, this is all negatively charged with a minus charge. So we have 6 fluorines. And we have 1 iodine. Then we add 1 electron for the negative charge. And that's going to be 50. So let's look at our structure. So let's see how many electrons we have. So look at the pairs: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So 48 electrons surrounding it. So we have to put a lone pair here. So this is going to be the same structure that we see with our xenon. So this is also going to be a monocapped octahedron because you're forming 6 bonds and you have one lone pair. And you have one lone pair on your iodine. So your electron domain geometry is going to be pentagonal bipyramidal, and your molecular geometry is going to be a monocapped octahedron. Let me just try to condense everything. And there we go. So remember, to do this kind of problems, you have to understand how to assign your electrons. You have to understand how to look at your electron domain geometry and relate to how your molecular geometry is.